So this is what's left scrapping electronic e-waste. Um, it was about a tractor trailer load, um, all garbage, scrap electronics. So you carry about 40,000 pounds in a tractor trailer. So we'll just say it's a half a tractor trailer full, and say it's 10,000 pounds. So looking at 5 tons around there, maybe. But this is what's left. There's 12 pounds. And the front row here it's all reverse electroplated sediment. There's no solids. This is the IC chips. It's all solids, basically. And the only thing that was reverse electroplated, shown in a previous video, it's this sediment here. So this is what come out of here, basically. What the other sediments are, we'll work on that later. But I'm not focusing on this right now. This is the little tiny pins in the IC chips. That's where sediment come out of. Reverse electroplating came off of that. The pins. And some of that. This is the IC chips at 150 mesh, around there. All the IC chips material was filtered and screened and meshed and all kinds of different ways of separating this material into categories. We'll look at that after. But these two right here is what come off the IC chips so far. And this material here is MLCC material. It's all solids except for these right here. We'll go over that another time. But there's MLCCs, there's 3.5 pounds, or 2.5 pounds. 2.5 pounds of MLCCs. That's what's left. That's what it is. I haven't thrown anything away when I processed my MLCCs. I didn't throw anything away processing the IC chips. Everything is right here. After wet washing and incinerating, I didn't throw anything away. The only thing was the ceramic dust, carbon dust. Because in the ceramic, it's separated in there. The ceramic's in these bags somewhere. I'll work on it more later. But there's a lot of separation. So in the IC chips, there's some 7 or 8 different types of metals in the IC chips. There's a few, 3 or 4 in the MLCCs. So these are reverse electroplated, recovered from the IC chips so far. 2.5 ounces and 0.8 ounce. So I got to work on that more. and I gotta work on this. It's not complete. This is complete. This can be melted. So everything that's been reverse electroplated can be melted and processed from there. See how it turns out. That's the next step, because I don't have anything else to work with. I've been doing this for like 10 years, and off and on as a hobby. But I haven't collected any more scrap electronics in the past 5 years. This sediment here was chemically processed, and that was 4 years ago, or 4 or 5 years ago. That's how long it's been sitting waiting. And I restarted on it, restarted working on this, and I started in reverse electroplating. And so this is what I recovered, and there's different stuff in there: sodium hydroxide and dropping and cementing with copper or aluminum or whatever it takes to get the hydrochloric back to a clear state, and where I can reuse it. Cementing and dropping, to clean the hydrochloric up is, well, this is the metals that were recovered. So if I use aluminum to drop out something else, well, I've collected aluminum, and that's someone's in there. There's different types of base metals, a lot of different base metals, and probably some precious metals in here. But that's another topic. This is what's left of everything. This is everything but IC chips, MLCCs, and pins and connectors. It's everything but that. Fingerboards, you name it. Everything was processed until I got to the point where, instead of depopulating the boards, reverse electroplating them, populated, and I'm not taking apart cell phones until they fall apart, if you've seen the previous videos. So this is 3.5 pounds. It's 3.5 pounds of IC chips, 2.5 pounds of MLCCs, 3 pounds of the big batch of pins and connectors, and everything else, these 4 right here, is 2 pounds. There's videos that I've done of cell phones and crystal oscillators and PCBs. These are in like categories for what to melt with what and what not to melt with other things. Like, see right here, this is where I reverse electroplated the hard drives. So this is palladium, maybe platinum, palladium. So I don't want that in with everything else. This is the the category for different burns or melts, but I can put all the apple foam sediment in the same crucible because it was all nearly the same stuff, and we'll figure it out later. I'll check it with a magnet, everything. I'll go through that real quick in a minute after we take a look at this. So it could be a lighter color to a darker color, but they still could be the exact same color of sediment. It's just I might have burned it hotter in the frying pan, the frying pot, dried it out different. But basically it's all, orange sediment. So to keep apart the let's see. We'll figure it out what needs to be melted and what after, but so this is the big batch of pins and connectors. Everything that come off. It's 3 pounds, and there's about 4 pounds of solid pins and connectors. This is all sediment. There's no solids in here. It's all been reverse electroplated, with hydrogen peroxide and water, spent hydrogen peroxide. And this is all the sediment that was bled and stripped off the pins and connectors. All the pins and connectors were depopulated off the boards, and then they were all plucked out of the plastic. And one by one, made them. So I started out with a full coffee can of highly concentrated pins and connectors, teeny tiny ones. There's some bigger pins and connectors in, but all of them are just so small. I mean, it's not like you're not going to have a lot of copper like you have with jewelry. So you can't consider the jewelry to be highly concentrated. Say hi. You say hi? Everybody want to say hi? Say hi. Bert. Hey, buddy. You sleeping? Everybody's relaxing. So what's next is the melt dish. And all this is going to get melted. Well, maybe two melts. All this together. It's all the same stuff. And see the penny and pins, visible gold on penny and pins, and an Intel chip and CCTV camera chips, and it all get melted together. The apple phones, the phone sediments, get melted together. PCBs, sediments that was collected off of them. If it's green or lime green or orange sediment, we'll get melt them separately, but basically it's just the orange sediment, and the green sediment is in the other bags, but it's all been organized and ready to melt down. So check it with a magnet real quick. So this is a neodymium magnet. It's got more pull than a microwave magnet. I'll just go through this real quick because mostly it's all non-magnetic. There's some bags you'll see that are, all magnetic, but mostly the sediment that's been reverse electroplated is just a little slightly magnetic. Most of it. A couple that pulls a little bit different, but overall it's not magnetic. There's one that's in there that's kind of got a good pull to it, and it happens to be a small amount in one of these. Just a slight pull, no pull. That's all the penny and pin stuff and stuff. But check this MLCC that hasn't been reverse electroplated, or chemically processed. This sediment was recovered from just putting on hydrogen peroxide on the MLCCs. Right here is this sediment here come directly off this sediment. I mean these solids, but the other stuff is everything has been screened and meshed, and processed like the IC chips. But you see, got some pretty good heavy amount in certain bags. But you see, most of it's magnetic. And this one right here, one of these two, is a lot more magnetic, and you almost rips the bag trying to pull it apart. So this one's pretty good. This one, it's real good. But you see, I've already got it. I already got them all separated between magnetic and non-magnetic, and they were meshed after separating the magnetic from the non-magnetic. This bigger stuff right here is 150 mesh and above, you know, like, and this would be, you know, like 100 mesh and above, and this would be like, this is 125 mesh. So it's different meshes. So this is the MLCCs, and I still have to work on them. But nothing. Slightly magnetic. Just a little bit. There's not much in there. I got written tantalum on there because I think it's tantalum. One of these two is the tantalum and the tantalum capacitors. That just might be iron or something. It's so this was a sodium hydroxide drop because it's from a sample. I did a small sample out of the MLCCs, and see the sediment that was produced out because um, so this sediment right here, when I was processing and filtering and just trying to break it down and get them into categories and trying to separate the metals in the water, just plain old water. So it wasn't this one here, but it was a similar batch that I done where this material came out of this in between these two materials. This is like a middle, and I separated them in two completely different materials. When I come to the bags, I'll show you which one it is. Because I got written on it top layer and bottom layer. It's at a minus, so this is minus 100 mesh. So they only make screens down to around 10 mesh. I don't even think they make a 0 mesh screen unless you go to a fish tank that gets a little bit smaller than 0 mesh, and then you get your solid coffee filters. You know, that's around 100 minus 100 mesh to 100 mesh. So if we're at 100 mesh and you go down to 0 mesh or 10 mesh, you go down to 0 mesh, and if you go below 0 mesh, you're into sediment that is not solid, soluble in water. Anything below 0 mesh is chemically processed, and that's the sediment that would be that you can't filter, that you can't be screened. So if you go 0 mesh to minus 100 mesh, if you were reading it through the micron, about 100 micron is close to about 100 mesh. If you go down the scale on the microns, you're going to be adding, so like 12,000 or so micron is about 10 mesh. So if you go like 50,000 micron, you go down like to minus 100 mesh. There's no scale for mesh below 0, unless you look at it as going to minus 100 mesh. But anything below 0, I found that gold is captured at 100 mesh. Around in 100 mesh is screened. It captures the, I think it's somewhere, around 100 is what captures the wires. The gold-plated wires, 24 karat gold, and the wires. But these came out of the IC chips, and they're wires. But I stripped them. I took a lot of sediment off of them. I mean, it seems to be a lot. It's like but they seem to be steel. I don't know. Magnetic. Probably, steel. The steel wires and the IC chips. I reverse electroplated them, and the stuff just bled right off of them. Back to the MLCC stuff. So this stuff right here really wouldn't grind down anymore. I use a coffee grinder to grind it down. Grind it and burn it, incinerated it. Mostly it's the black transformers. This is non-magnetic 100 mesh. It's slightly, hardly any heavy. So this was separated, with screening and filtering the 100 mesh. So I figure this would be 150 mesh around there. Slightly magnetic. It says magnetic, but it's slightly magnetic. That's screened at 150 mesh. This is around 100 to 125 mesh. Very magnetic. almost sure he ripped the bag to get it off of there. It's magnetic, 125 to 150 mesh. Very magnetic. It's 150 plus. Not magnetic, hardly at all. So I probably got some small IC chips mixed in with the MLCCs, because they're just scraping the boards and pushing everything into a container. So I just scraped the boards, depopulating them, and scrape them with a putty knife and a hammer. That's all you need. You can scrape a PCB completely clean with a putty knife and a hammer. You don't need no electric, no heat. You can put the putty knife on a processing chip, and you can split off the heat sink right off the chip. Do it all by hand. No need for. This is 150 to 200 mesh around there. It was just forget the 100 or 125 non-magnetic. 125 non-magnetic. It's all the MLCC stuff. Two and a half pounds. 2 pounds. 2.5 pounds in the MLCCs. So this is a little sample that I did, a little test that I did. Out of this one right here. I didn't use Comet, I used bleach. First soaked the sediment, the material. It's just a sample. It's just a sample of everything all together. Just took it to the side, soaked it in hydrochloric, and then it was brand new hydrochloric, and then after that I just added bleach, a cap full of bleach, and if it did anything more I might have added another cap, but this is what drops out of it right here. Don't want to breathe it. replace a magnet. This is a IC chips, reverse electroplated, slightly magnetic. This is not magnetic at all. That's 2.5 ounces. That was in the IC chips. Reverse electroplated. Slightly. So there's 3.5 pounds IC chips left. And like I said, didn't throw anything away except for carbon dust. I processed the mud, screened it, and filtered the mud. It's all right here. It's right here. These right here are camera IC chips. A couple ounces there, but they were separate from the IC chips, the big batch. I kept them separate because they're just a better quality chip than the regular IC chips. So we know there's a lot of magnetic stuff in there. I mean, not too much, you know, in some of them, but some are more magnetic than the others. I didn't separate anything with the IC chips through with magnetics. I didn't do anything like that yet. So I got them, you know, this one's 100 mesh, right at 100 mesh. See the silicon. Figure that out later. This is -1 mesh. -1. Different. So this one might be minus, or it might be 0 mesh, or this might be 1 mesh, but there's a difference. It all came out of the same stuff. And this is all solids, you know, hasn't been processed. All it's been is screened and filtered. So I got this at between 1 and 5 mesh. So if you turn a food filter around, you can go lower on a screen filter, because you can only go so low on screen filters. And then you get a food filter. You turn the food filter around and you get you get your 1 mesh or 5 mesh. Between minus 10 mesh and plus 10 mesh. Non-magnetic. This same thing. Somewhere in the area between minus 10 and 10. They were separated, out of the mud. The IC chip mud. Yeah, they're separated, in water. Some dry filtering, dry screening. But you have to watch the videos to look it over, see what it looks like. So I figure this to be 15.5 mesh. Non-magnetic. So like I said, there's a number of different types of metals in IC chips. There's more metals in IC chips than on a PCB board. More different types. This is the pins and connectors. I mean, not the pins and connectors, but the pins out of the IC chips. So these are the small pins. Be like 100 mesh or so, something like that would capture these here. This might be above 125 mesh or something. It's got a slight green tint to it. The pins. So this I got is a 1 mesh. Powdery. Very fine. This is the fiberglass that was screening the IC chips. This is in the IC chips. You've never seen this before. You get it in different ways or whatever, but cottony, real light, slightly magnetic. But there's still metals in there. just do this. Cut through this real quick. There's not much more to see. It's just a bulk. Just the bulk of the mud magnetics. Some is non-magnetic, but you get the idea. It's all been screened and meshed into different categories. That can mean that it's metal or some kind of different metal. How fine it is. Could be silicon sand. So the sand could have separated the sand from the gallium, or the the sand right from the glass. See, this is the camera IC chips. These are from the camera chips. The chips are behind any video camera. There's a chip behind it. That's what these are. Not magnetic. That one's magnetic. Non-magnetic. A little bit. So this was screened. Wet screen at about 5 or 10 mesh. There's still a lot left to do with this. I haven't put much time into it. But this right here can be melted. These right here can be melted. A couple more in there can. So the next will be either melting or trying to dissolve some base metals out of it. So if I take this, like this bag right here, and put it in hydrochloric, and it's at a certain screen or mesh, if whatever it dissolves and whatever it leaves over, well, that's another day. take a little sample of it and and just put it in some drain cleaner or whatever you plan on using. Just the solids anyway. So these are not solids right here. This is sediment. This is all solids of the IC chips. And this small amount right here is a sediment, and specific, different, and it'll be processed. So this is all from the cell phones that I've done in previous videos. Sediment collected. You can just throw this all in the same dish and melt it right all together. This is from a big batch of pins and connectors. So this is some of the green sediment that come out, lime green, come off of, most of the sediment that come off the pins and connectors is orange yellow, like this. But, so that's why it's set aside. That's why these are set aside, because they're not gonna get melted with this. Just about all this is going to go in the same melt dish. It's all the same stuff. So this one's a slightly magnetic. Slightly. Nothing on the other ones. So that's 3 pounds. 3 pounds came off the big batch of pins and connectors. There's no solids. It's all sediment. These are the, see in the previous videos, this one's a 6 large PCBs, and then the other one's a 3 PCBs, but it all has to do with PCB sediment from running PCBs. Instead of breaking everything down and depopulating the boards, I'm leaving the pins and connectors on the boards. Everything just stays on the boards, and once I run it the first couple times, all the components, they weaken up and they just scrape right off real easy. But it's easier to get the IC chips. I still have the PCBs. I still have to process all of them. This is just a small sample of the PCBs. All visible gold plated on the PCBs. Usually the first run will be an orange, royal orange sediment. And then the second run will just about be a lime greenish type with the blue. It's a blue and orange sediment mix. But mostly the first sediment that comes off a PCB is orange. And if it usually collects on steel, and it doesn't degrade steel. Reverse electroplating I found is a little bit on the steel, depending on what part it is, but it doesn't affect aluminum. There's probably nickel and everything, right? Probably a combination of nickel, silver, and the big pins and connectors. There really isn't any silver. There's some, but it's mostly was gold plated, etched, electroplated, or um, that's the various other videos I've done is Toshiba laptop and Toshiba, Did quite a few runs in a Toshiba, organize it later. CCTV blue sediment. It's penny and pins. There's a black sediment that came off of it. There's the hard drive discs. So when I'm done with the hard drives doing this, the hard drives are clear, transparent. And this is what come off of it. As long as you keep everything in the glass, your platinum and palladium, you keep it in the glass, and don't let it. Same with aluminum. Aluminum is pretty dusty. Because I tried to reverse plating with using aluminum fence wire, and it just creates a dust, basically. It's so light. So I'll be going through this some more, looking it over and see what needs to be done. But like I said, this was processed a few years ago. I've been sitting there for a while. So this right here, this here is was just a little test of what it did was I had some boiling hydrochloric, and it was a good pH, and what I did was it was dirty, and I couldn't get it any more clean. So what I did, I just dropped some sodium bisulfate into warm hydrochloric, and it crystallized in midair in the water. I mean, in the hydrochloric, but it just crystallized. I just poured it off, but then it just crumbled. just a little test. So this is good here. Got a good little explanation. Progress. Not much more, but so we'll just say it was 5-10 tons of just say 5 tons of scrap electronics, and 10,000 pounds or more. That's what's left. So 12 pounds. The MLCC is 3.5. 3.5 on the ICs. 3 on the pins. Another 4 or so of solid pins and connectors. They're already stripped. There's not that much more of this sediment coming off the big pins and connectors. It's more of an iron color sediment. It's not royal orange. But there's still visible gold left in the big pins and connectors. Not much. It's hard to find. It completely lost its color. All the colors in here. And 2 pounds in the assortment. So there's about 12-13 pounds left. That's what recovered from 5-10 tons of scrap electronics, cell phones, towers, you name it. Next thing is melting. The weather has to be good, because I ain't doing it inside. Lights out.